What is up, guys? 70 Savage here, coming at you today with a brand new video. Today we are working on part 2 of this electrical series, where we are going to be putting together our electrical system inside the van. If you missed part 1 of this series, I highly recommend you go back and watch that one. Part 1 covers all of the concepts that you need to know in order to understand what we're going to be doing in this video. We are going to keep the structure of this one exactly the same as we did last time, so that you can mentally map the concepts from part 1 to the execution in part 2. We're going to start with the batteries. We're going to move into the 12-volt DC system. We're going to go into the 120-volt AC system, and then we are going to cover the battery chargers. If you are new to the channel, I am the kind of person who always comes up with tons of crazy ideas, and to be able to turn those ideas into reality by knowing how to make them is one of the most empowering feelings. That's what this channel is about, is learning how to turn your ideas into reality. If that is something that also interests you, then slap that subscribe button below, because we are going to keep making content. Speaking of making, let's go ahead and make it happen. So right now, this is what our van looks like. We finished most of the cabinets in here. What we are going to be doing in this video is the brains of the electrical system, which is all going to sit in this cabinet right here, made out of 80/20. In fact, everything in this van was actually framed out of 80/20. If you want to learn more about how to actually build stuff with that material, I have a whole video on it on the channel. Just a warning, this video is insanely long and it is insanely detailed. I asked you guys in a post a few days ago if you wanted the long detailed version or the short abstract version, and about 99% of people wanted the long detailed one. So here we are. It might make sense to do an overall recap of the system that's a much shorter, less detailed video. If nobody ends up watching this one because it's just too long, then I'll probably do that. We have 6 170 amp hour batteries. That brings us to over 1,000 amp hours of total battery storage. And did I mention that they're all lithium? Slap subscribe so I can pay rent next month. This is more battery storage than I've ever seen in any van anywhere on the internet. Now, I'm sure you guys can prove me wrong on that, and I don't even have to ask you guys to put it in the comments. In total, these batteries weigh almost 300 pounds, which is why they need to be really strongly secured in this cage here, so that when this thing's off-roading, they're not going anywhere. The reason that I went with this many batteries is because in my last van, I had 400 amp hours in total, and they were just AGM batteries. And my number one biggest complaint about my last van was that I didn't have enough electricity. I might have gone just a wee bit overboard. Not to mention that AGM batteries, you can only drain to about 50% of their overall capacity before you permanently damage them. Whereas these bad boys, the lithium ones, you can drain 80% of the total capacity, which means that in my last van, I had about 200 amp hours of usable capacity, where here I have about 800 amp hours. The other awesome thing about lithium batteries is that they weigh way less than their AGM counterparts. So anyways, let's go ahead and put all these batteries where they belong so we can get to wiring things up. We got our battery bank in place here. Each one of these batteries has a positive and a negative connection, as with any 12-volt battery. And the first thing that we're going to do, which I already did on these 5, as you can see, is what's called a terminal fuse. If there's a short between any of these batteries, the terminal fuse will blow and stop the circuit. You might be wondering, well, there are no loads between these batteries, so how could there possibly be a short circuit? That is exactly what I thought on my last van, until I accidentally dropped one of the battery cables and it bridged the positive and negative terminal and immediately melted the bolt, and it scared the crap out of me. Each one of these terminal fuses is 300 amps, the maximum amount of current that I expect to draw from my entire system at any given time. The BMS, or battery management system, that's built into each of these batteries would probably do this job anyway, but not looking to test that one out again. We have all of our terminal fuses in place. Next up, we have to turn each one of these batteries into one big battery bank. The way that we're going to do that is connecting the batteries in parallel. What that means is you connect all of the positives to each other, and then you connect all of the negatives to each other. We're going to do that by making our own battery cables that are the perfect length to fit in between each one of these terminals. You can definitely buy pre-built battery cables, but it's actually way cheaper to make them yourself. And with these super thick battery cables, it is pretty important that they're the right length, because they don't bend very easily. Before we get into this, I have to make sure that you understand the risks and the dangers with doing anything electricity oriented. In my last video, I I said you should just not do this yourself and you should hire a professional. I no longer agree with that, but I am not gonna be liable for any harm or injury that you cause to anything at all. You have to do this at your own risk. All of this right here is the stuff that we're going to use to make our battery cables. We have 2 spools of 2/0 wire, 2/0, which is different than 2 gauge. It's actually quite a bit thicker. My favorite brand of wire is Anchor for everything. It's a marine brand and they make tinned copper cables. So I don't know how well you're gonna be able to see this on camera. Although these are copper strands, they're coated with tin. So they resist corrosion a lot better than regular copper wires do. I'm putting links to all of these products in the video description below, including the wire and all the tools that I'm using. This is also the same stuff that's on my wiring diagram in the video description below. This might be kind of silly to some of you guys, but when I first got into this electrical stuff, I didn't really understand that wire literally just meant wire. The red and the black wire are exactly the same. It's just the color of plastic on the outside that helps us as humans interpret what that wire should be used for that's different. The actual stuff inside the red and the black wire are exactly the same. Just wanted to throw that out there. Let's start by making just one cable for the positive side. Oh, this one takes a little bit of force. Next thing we're gonna do is put one of these lugs onto this cable. In order to do that, we need to trim back some of the insulation. The thing about putting these lugs on is it's just as easy to take them off. So what we need to do to permanently attach this lug to this piece of wire is called crimping it. For these big wires, you have to do something very different than what you do for crimping small wires. For any wires that are bigger than like an 8 gauge or so, you wanna use a big wire crimper rather than those little handheld ones. That brings us to this bad boy right here. This is a massive hydraulic wire crimper. I think it was about 80 bucks, pretty expensive, ridiculously heavy. It weighs like 20 pounds. There's a much cheaper version of this, which is a wire crimping anvil. I'll put a link to both of them in the description below. You just start cranking on it like this. You gotta give it a little bit of muscle and boom. Just like that, we have a perfect wire crimp on this 2/0 cable. It is insanely strong. I'm pretty sure you could hang from this and it just wouldn't come off. So now we've got ourselves a fully functioning battery cable. It would work perfectly in its current form, but we can do one more step to make it look professional. We are gonna put a piece of heat shrink around it. It comes in all different shapes and sizes for different sizes of wire. All that you have to do is slide it on like this, and then you take your heat gun and you heat it up for a little while. Surprise, surprise, our heat shrink actually shrunk. If you look really closely, you can see this heat shrink has glue in it already. It's heat activated glue. Our battery cable is complete. Let's go ahead and try it out. So we finished all of our battery cables and we now have one giant connected battery bank. There's a link to these Renogy lithium batteries in the video description below. Next up, we have to run a wire from our battery bank to our electrical panel, which is gonna live down here. Alrighty, we got our piece of wood. It is loosely bolted in place. Before we actually attach this battery bank to anything on that board I just showed you guys, we have to install this master on-off switch and this master 300 amp fuse somewhere on the front side of this panel so that it's easily accessible. If there's ever an emergency, I can just open the rear doors and flip it off. Alrighty, our first component is installed here. It is a switch that comes directly off the positive side of our battery bank. There's just a long wire that gets routed through the bottom here. It comes up into this 300 amp breaker, which goes into the input side of the switch. I'm using a 300 amp breaker because this is kind of a 300 amp system, right? We have 300 amp terminal fuses there and all of our hardware is going to support 300 amps. This is a 3000 watt inverter, so I can run this inverter and use some of my DC devices without blowing these fuses. Now that we've got our battery connected to the input side of the switch, we need to connect this output side somewhere. Now this is where our bus bars come into play. Now that we've got the bus bars mounted, all we have to do is route the output from this switch to the positive bus bar. Don't forget to turn it off. We got the switch connected to the positive bus bar. Now what we have to do is take our negative and bring it back to the negative bus bar here. The reason I'm taking the negative on this battery and not on this one is because we want the current to run through the whole battery bank. If I were to just hook up this negative terminal here, most of the current would be flowing right here and it would pull some from the back, but not nearly as well as if we do front to back. Now, before we take our bus bars and start powering all of the things, we need to ground our negative bus bar to the chassis of the vehicle. So even though this is going to be what's called a floating electrical system, meaning that all of the current in the system is flowing through wires that we're adding to it, we still want to ground it to the chassis just in case we like cross wires with the Mercedes system and just for general safety reasons. I'm choosing this location right here because it's actually twice as thick as the other metal in the same area. It's pinch welded to the rest of the wheel well. Very, very sturdy ground location. Before we actually start drilling, we're going to take our Dremel and we're going to clear off the paint and the clear coat so that we expose the bare steel of the location that we're trying to drill through. So now we've got our nice exposed steel grounding location. Let's go ahead and attach the wire. Of course, I got the wrong size nut. Back to the hardware store. I think this is the cheapest I've ever made it out of the hardware store. Since this is the only hole in the entire van that we're gonna drill and not put paint on afterwards, I wanna make sure that we're not gonna get any rust over time or any sort of corrosion. We're gonna spray this stuff on it right here. It's actually meant for electrical components and preventing corrosion in the long run. You can find this at your local hardware store, but I'll also put a link to it in the description below. It's a nice, secure, large surface area connection into a really sturdy part of the frame. Now that we've got that hooked up, we can test it out by doing something pretty cool. We have our multimeter here. We can take the positive side, touch it to the positive side on our switch, take the negative side and touch it to any bare metal in the van whatsoever. The same 13.2 volts is flowing all the way through the van back to our battery bank. So now that we've got our big ground wire coming all the way around and attached to our negative bus bar, we are finally ready to start actually connecting devices. As we covered in part 1 of this video, we don't want to directly connect the bus bars to all of our devices. We need to have some means of protected distribution where we can have fuses on all of the wires that are going out to those devices. So what we're going to do is connect the bus bars to two 12-volt fuse boxes here. The only reason I have two is because I might end up having more locations being used than are available on just one of these. And there we go. We got our two 12-volt fuse boxes ready to go. We have two big negative cables. These are 4-AUG around the back of this board attached to the bus bar right here, as well as two positive cables with also 4-AUG. Each one of these fuse blocks can carry, I think, 80 amps or 100 amps. I can't quite remember, but I have 100 amp breakers in front of them to make sure that each one does not pull too much current individually. Let's test things out with our handy dandy multimeter. First, we gotta turn the system on. And if we check positive to negative here, we got ourselves 13.2 volts. If I take my hand off, it goes back to 0, on, back to 13.2. Now we have a ton of places that we can put individual 12-volt devices. There's positives here, which have their fuses, and then negatives for each device. Let's start with an easy one. We have this max fan that we've completely installed and it has its positive and negative hanging off. See if we can make it work. So the way that we are going to get this wire down through the side of the van and into the electrical system is with this little guy called a fish tape. Basically, it is a fairly, almost dropped it, fairly rigid piece of steel that you can finagle your way. Basically, I'm going to go through this. Oh my God, look at that bee. No, don't nest in here. Hey, what the hell? Bee just tried to start a hive. This fish tape goes down through the side. You can then tie your wire to it and pull the wire back out. Makes it way easier to get wires in these small places. So once you get down to working with this 14 gauge wire, things get a lot easier. First step that you gotta do is just remove the outer insulation that covers both the wires with a knife. Once you're done with that, you have both the black and the red wire exposed. You wanna take one of these electrical wrench thingies, electrical pliers, I don't know. I'll put a link to these in the description below. They let you crimp and cut like 22 all the way down to 10 gauge, which is pretty much all of the small stuff that we're going to be doing. We want to remove enough of the insulation on both sides of these that we can join them together. So we take the insulation removing part of our pliers here and we cut off enough insulation. These are the quick disconnect insulated joiners. I really like to work with these. They're really simple. This is what they look like. There's just one male and one female side, and all you gotta do is attach them together to create an electrical connection. And we're gonna crimp our wire ends on each of the sides. To do the crimping, we can use these same multi-purpose primers. We're gonna find the section for insulated terminal crimping. We're gonna go down to the 14 gauge, and we're gonna crimp one of these to each side. It's pretty confusing, but on this fan, the black is actually the positive. I don't know why they did that, but because it is labeled positive, we're gonna connect it to our red wire and the white to our black wire. And now we are good to go on this side. Now all we need to do is take our cable here, pass it behind the walls, back around, and into one of the locations on our 12-volt fuse box. The reason I have these quick disconnects as opposed to these standard kind of permanent butt connectors is exactly for this reason right here. I've threaded this wire all the way down and navigated it, but I realized that I actually need to put this behind the beam here. So with these bad boys, I can just disconnect it and reroute it, no problem. By the way, these quick disconnect connectors are also great for anything like switches that have these metal pins on the back. Ends up looking like this, and I use these for all of my switches and relays, anything with these pins sticking off of it. On this side of the wire, it's pretty similar to the side we did up there. Now this time around, since we're not joining two wires together, we're instead mounting these wires to the fuse block. We need a bit of a different connector. I like to use these same Anchor branded terminal connectors. First thing we do is just slide over the top, same as the previous connectors. We're going to use our same crimping location for insulated 14 gauge. Make sure it's strong, which it is. We are going to connect our positive and negative to the first location on this fuse box. And I actually don't have any fuses. I need to order some in the mail. Thankfully, it does come with one. This is a 15 amp fuse, which I would not use for this fan. I think I would use a 7 amp. I can't remember the number. I'll put it on the screen right now. You want it to be pretty tight, nice and snug. Same thing for the negative. We're just going to take the first location here. Let's call it this one. It actually doesn't matter which negative location you use. They're all the same exact negative connection. And just like that, we have our first, hopefully functional circuit. Let's turn it on and see if it works. Oh, power button. Hey. Let's get it. This is the moment when you really feel like you're some sort of Thomas Edison who just invented a light bulb. Very satisfied right now. Super stoked this works. Something else I learned is that if you do have multiple Max fans, one remote works for all of the fans that you have. That's definitely going to get frustrating, I can already tell. Before this next step, I think it's probably important to give some context of what the kind of end result of this electrical system is going to look like. The idea is to put our control panel where we're going to see our battery monitor, our water tank levels, have all of the switches for turning things on and off in the van. Right here, located above our comfy seat, we have two options. We can either run the wires up and over the roof, back down and into the battery bank, or we can run them down through the bottom of the van and up. In the last van, I did run the wires over through the roof. It's definitely not a bad option. It worked pretty well, but the main reason I decided to do that was so that I didn't have to drill any holes, when in reality, you have to drill holes either way. If you're gonna go over the roof or through the floor, you have to drill holes through somewhere. Now that I know that, I think it's actually gonna be simpler to just drill 2 holes through the bottom of the van and run the wires underneath. When you run them over the ceiling, you have to take your whole ceiling off anytime you wanna change that wiring. And that brings us to the absolute worst part of this electrical install. We have to drill holes in the floor of the van. First, we're gonna start with a small hole just to make sure that we didn't miss the mark. Hey, let's go. We got the perfect location. Time to use the Big Daddy. I definitely recommend using full-on goggles when you're drilling up underneath the van because all that crap falls straight into your face. Check it out, guys. We got ourselves a perfect 3-inch hole. By the way, the reason you want to start from the bottom of the hole and then finish from the top is to abide by an old Drake saying of started from the bottom, now we here. You want to finish from the top so that it's a nice clean cut downwards and it doesn't have any blowout. Last step, we're going to rust protect that hole that we just cut by spray painting it with this. This right here is what our pass-through contraption looks like. We have the cable boot with a little plastic ring on it. I fabricated this piece of aluminum by cutting a 3-inch hole-ish kind of shape. On the back side, we have some weather stripping. This is 3/4 inch. It needs to be thick enough to fill in those ribs on the bottom of the van. There are going to be big screws placed through these corners up into the floor of the van. And then we have 6 small tapped bolt holes in here. These are 832 tapped bolt holes. You can see the threads. Those 6 threaded holes are going to allow us to mount this cable boot. So if you want a really good ab workout, I suggest you install something like this. Getting this thing installed into this crevice was way harder than I anticipated. It literally took me like 4 hours of basically doing sit-ups. So this right here is how it turned out, guys. I am super stoked with how it's looking here. Not only is it super secure, but as you can see, that weather stripping is conforming to the underside of the van. So we have a perfectly sealed waterproof cable entry. It's gonna be really easy to either add wires or remove wires because all we gotta do is change that zip tie out. But now we are finally good to run wires across the van. So on the driver's side of the van here, we have finally completed our wire highway. Starts from this cable boot right here, which is just in front of the shower, and into the cable boot that's just in front of the electrical bay. Now that our wire highway is built, it's really easy to just run all of our wires in this exact same way. By the way, we are going to put some conduit on the outside of our wires, so don't worry, we're not going to leave them like this. The first 2 wires that we ran underneath the van in that wire highway are this max air fan that's in the front of the van, as well as the wires attached to our lights on the roof rack. Next project is also a biggie, and that is hooking up the ceiling lights. This front zone is going to be turned on with this nifty light switch that I have installed right here. This is a dimmer switch. It's kind of a low profile version. This right here is the diagram for it. So you can see they have a black that goes to ground, but then they also have a red that goes to the ground on the lights and a white that somehow goes to positive. I think this is really confusing because most switches kind of intercept the positive wire. And the thing here is that this switch actually intercepts the negative wire. So what I'm going to do is actually bridge the 2 positive wires, one that goes out to the lights and the one that goes into the battery bank, and then leave the 2 ground wires separate. One of the ground wires goes to the lights, one of them goes to the battery bank. That gives us 3 positions in total. The light is now dangling attached to that 1 wire. Let's go ahead and see if it works. Hey, we got full-on damage, baby. You want to hook up all your lights in parallel so that if one of the bulbs goes out, it doesn't turn all of them off. That means that each connection requires you to bridge it with the next light's connection. So this right here is what each connection ends up looking like. By the way, these lights are super low power. They draw like 200 milliamps. This entire front section of lights is gonna draw less than 2 amps of power. So 14 gauge wire is way overkill, but I have a massive spool of 250 feet of it, so I thought I might as well just use that. All right, we got all of the front lights working with this switch right here. And then coming into the back, I have the switch dangling right now because I don't know exactly where I'm going to place it. It turns the lights on back here, which I only have 3 of right now because I do need to order more of them, but the whole circuit's working and we are good to go on lights. We just got the fridge connected. It actually works, which I am very pleased about because I am well outside of the return window. It was super simple, literally just a positive and negative to this fuse block like all of the other 12-volt accessories. It's a little dirty up here right now, but we have our 6 Baja Designs lights. We have them attached with the waterproof connectors, and then they go into these cable clamps directly through the roof. I put a little Sikaflex on top of them. I'll put a link to these cable clamps in the description below. I think this is the best way to run wires through the roof of the van. They go through the roof and come out through the insulation right here. We have them running back inside of the wall here into our cabinet, where we have them run down, down, and then out through the cable boot. I did use the massive harnesses that come with the Baja Design lights. I've had the lights mounted for months and I've never actually turned them on because we needed to attach them to our house battery bank rather than the cars. They drain way too much amperage. So when it gets dark tonight, I'm gonna turn these puppies on and show you guys what they look like. So it's been about 2 days since the last clip I filmed. We still have those 3 wiring harnesses that are coming from the roof there. But trying to get these 3 wiring harnesses actually turning on the lights has proven extremely challenging. Holy cow, guys, you have no idea how stoked I am right now. I finally got the lights working. Boom, remote switch. We can hook this puppy up to the dash. That took me way longer than I originally thought it would. Low beams. High beams. Look at that spotlight. It literally is so bright. The entire area here looks like daylight. So the challenge is I was using the harnesses that you can buy alongside the Baja Designs lights. These come from them. But since I have 6 of those lights, I had to cut all the harnesses apart and kind of jerry-rig my own logic in there. And the strangest part about it was that the signal wire to this relay was causing those lights to give like a low voltage signal where they go blah, 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 blah. And it was just the signal wire to the relay. So it caused me so much confusion. I had to track down with the whole system as far as where the voltage drop was actually occurring. And I finally found that it was on the signal wire, which shouldn't be doing anything. Anyways, what I did was I hooked up a second relay after their relay that has signal wires that don't require a ton of amperage to go through them. If I would have just rigged these things up without their wiring harness to begin with, it probably would have been a lot easier. So relays are a whole separate concept that I didn't cover in part 1 of the electrical series. The main reason you use this piece of hardware right here, a relay, is if you want a lot of power to a device, but you want to power that device from somewhere very different. You also want to use relay if you just have a massive amperage device that you want to switch on and off. Typically your switches can only support about 10 or 15 amps. So if you need to use that switch to turn on something that takes 300 amps, you basically connect that switch to the relay. And then when the relay sees that the switch is on, it connects the power wires to each other. So you can pass 300 amps through the relay and still only pass like 1 or 2 amps through the switch. Don't let that confuse you. You're probably not going to need relays. I didn't use a single relay in my first van. So as part of this endeavor for the lights, I actually hooked up another sub panel in the tall cabinet. This sub panel is connected to the batteries with massive 2-AUG wire. That big 2-AUG wire goes out through the bottom of the van, gets run underneath, and is connected to our big bus bars. The reason I did this is very similar to the reason you'd hook up a sub panel in a house. I basically have a ton of connections in the front of the van here. I have all the lights on the roof. I have my fan above me. I'm also going to put a couple of outlets down here. Instead of running all of this stuff out through the bottom of the van and back to the 12-volt fuse boxes over there, I decided to put a 12-volt fuse box here so that we could run much shorter lengths of wire for all those accessories. By the way, this is still super messy. I'm just so stoked that I finally got these lights working that I thought I'd film it now. We are going to clean this up and bundle all the wires nicely. So we're currently taking all of those wires that we powered from the sub panel that we installed, running them underneath the floor, back up through the bottom of the driver's seat with the factory boot. And then we want to run them up so that we can power them from the dash here while we're driving. Anytime you get anywhere close to the OEM factory wiring, your brain just about explodes. It is all super, super annoying. On my first van, I didn't touch this stuff at all. I did not bother to run the switches all the way to the dash, and instead I just switched them from the back. So we have all of these switches wired up to the dash here. These are the OEM factory dash switches. I actually ordered some custom dash switches that slot in here, and we'll be able to accept these pins. For now, I tested it all with these temporary switches and everything is working great. Next up, we have a super exciting part of this project, which is going to be the electrical control panel. This is gonna be the thing that we're actually using on a day-to-day basis, unlike all that complicated stuff inside the cabinet. And the idea is that we're gonna have a nice door we can swing out to use all of the stuff in there. So I'm gonna pull this panel down and we're gonna build a box real quick. The way that we're building this electrical panel, I have this box which sits permanently on this face of the cabinet, and then we have this false back that's going to be screwed in inside of here where we can mount all of our electronics to. So anytime I have to go in here to do maintenance or to add anything, all I have to do is pop this false back out and I can do my work there, pop it back in. There's not too much work needed to change things up. And then we're gonna have this door that opens up to expose all of the electronics. Take a look at how it turned out. Obviously, I'm gonna need to repaint this right here. I gave up on that pretty quick as far as trying to keep it in perfect condition. And we have to do a bunch more finishing touches, such as fix all these mistakes. But if you ignore those, this is completely functional and it actually works really, really well. We got the AC controller, we got the heater controller, we got the max fan controller, inverter switch, all of our 12-volt DC switches, battery monitor that actually just hooks to our phone via Bluetooth, and water tank gauge. The very last 12-volt DC device that we're installing in this video is the cell signal booster. I put it behind the microwave because I had quite a bit of extra space. I thought I could put some devices back there. This one is the Cellfi Go X. It's supposed to be the best one available. There are a few different connections for cell signal boosters. The first one is the antenna that I currently just have out the door back there onto the roof. It's just a magnetic antenna That's a temporary solution until I get a full-on mounting system. That's what grabs the signal from the cell towers, puts it into this device. The device amplifies it, and then you have an inside antenna, this guy right here that I just have taped to my beam. That's what broadcasts the signal inside of your van so that your cell phone can connect to it. And then obviously you have power, which I've hooked to that 12-volt fuse box. And we have a nice switch that we can turn it on and off here. You can see my fancy label. That switch for our cell signal booster is the most basic version of a switch that you could possibly have. The way that it is run, this black wire is the wire that connects directly to the cell signal booster that came with it. I cut it down and stripped off the two ends. Instead of attaching the positive of the cell signal booster to the 12-volt fuse box directly, I took the positive, routed it to this cable, which I have back to the switch. This intercepts the positive. This goes to the switch, all the way back out, and the other side of the switch is attached to power, so that when the switch turns on, we get power through this wire and up into the cell booster. Then we just have the ground cable, which is this one right here. Same as all the other ground cables. Okay, we are finally done with all of the 12-volt DC devices. Most of the work is in that part of the system because that's where you end up routing all of your distribution. We're also going to be hooking up a lot more 12-volt devices as the build progresses. All the other 12-volt devices that we end up hooking up, one positive, one negative to either of the DC fuse boxes, and we are good to go. Next up, we are going to install this inverter, which is going to power all of the 120-volt accessories inside of the van. For us, that means things like the water heater, the microwave, and all the 120-volt outlets. Ours is a 3,000-watt Renogy inverter charger. We'll basically need to mount that to the 8020 right there, and then run the distribution out to a 120-volt AC panel that we're going to put right here. It's very similar to how we ran our DC distribution to these 12-volt DC fuse blocks. Alrighty, so we have made some progress on the inverter here. We have the input from the battery bank, the positive and negative input. Those go directly to the bus bars, and we have our first output here. So this looks like a big cable, but it's really just a round version of 3 cables, the hot, neutral, and ground. That is 10 gauge because it is powering our entire AC distribution panel, and that all works. I can go ahead and show you guys. This is the remote switch for the inverter here, and when I turn it on, it beeps annoyingly for a few seconds, and then you can see our AC voltage works. So outlets are pretty simple. They're just labeled hot on one side, neutral on the other side, and then you have your ground location there. All you got to do is strip your wires and attach them to each location. The other side of our wire is just attached back to that 120-volt fuse box that we talked about. The microwave is very easy as well. We have just bought an extension cord from the hardware store, the shortest one we could find, cut off the female side of it. We crimped it to our 320-volt wires, the same way we crimp all the other 120-volt wires. I know it might be surprising for some of you who are brand new to this. I was like, holy crap, 120-volt AC extension cords are literally just the same 3 wires. But anyways, we can now plug this in to the plug that comes with the microwave, and we run the wire all the way down into our 120-volt AC distribution box. Link to this microwave in the video description below. It's actually the smallest width microwave that I could find anywhere on the internet. By the way, have I mentioned yet how absolutely amazing it is that I can simply pull off these panels in like 30 seconds. You can tell that the person who built the van is also the person who owns the van when your panels look like this. Bolts. That wraps it up for all the 120-volt AC devices. Let's move on to the final section that's going to use both the 120-volt system and the 12-volt system, the battery chargers. The next thing that I want to hook up is the AC input. This is going to allow me to charge my battery bank before we get the solar panels installed, which is going to be a different video. Step 1, we got to run this same 10-3 wire out through the bottom of the van towards the back. So we've got our wire run all the way to the back of the van here. As far as shore power goes, most people will actually drill a hole in the side of their van and put a small panel. I did not want to drill a hole in the side and have that panel be visible because I feel like it kind of gives off that RV look. And I want to go for something a little bit like stealthier. Not that this van is stealth by any means, but I think it's going to look a lot better if there's not a big plastic panel on the side of the van. So what we are going to do, as you can kind of allude to with where this wire is coming out, is put a recessed, hidden shore power inlet underneath the van here. We're going to use 3 components to build our shore power inlet. This is a Marinco 30 amp stainless steel inlet with 3 prongs there. We then have this waterproof aluminum box that we just bought off McMaster. I'm going to attach the inlet to this side of the box so that we can connect our wires inside of this little waterproof location. And then in the back of the box, we're gonna drill another hole and put a nipple that our cable is going to go through. I will put a link to these 3 parts in the video description below. And there we go, we have completed it. You can barely see it on the bottom right there, which is the intention. I actually broke this stainless latch, so I have to order a new one. Ignore that. But we have our box that's completely water sealed. We have the wire coming in the back that gets routed up to the inverter. And what you're gonna do when I get a new one of these is you twist it, you open it, you're gonna be able to plug your power in. You can see I have the 3 wires routed through there, through a cable gland in the back. That's all watertight. More brokenness. And yeah, we're good to go. I might paint this black at some point and maybe this as well, but I have so much stuff to do on the van right now that I can't dedicate the time to that. So when it's closed, this thing is about 3 inches higher than the bottom of the spare tire carrier that I don't have my spare tire in because I have it on the back. And it's about 2 inches higher than the bottom of the exhaust. Basically, it's a little bit lower than the bumper, but if you're gonna need this extra 1.5 inches of clearance on the off-roading you're doing, you're gonna mess up your bumper anyway. If you don't care about departure angle, you could actually mount this even farther down and more out so that it's easier to see when you want to plug your outlet into it. For me, this is the perfect location. All right, let's plug in the power and see how it looks. So now if we come over and look at the input, we can see that it absolutely has voltage coming through it. And when we look at the app for the Bluetooth battery monitor, it is also showing that we're gaining about 85 amps of power right now. So we finally have a good way to charge our batteries. That actually went pretty smoothly. On to the next thing. I know a lot of you are probably watching this video just waiting for the solar install, and I have some bad news. I'm going to do the solar as a separate video. It's a big enough project on its own that I haven't started. That being said, we do have the solar charger mounted with the 2 breakers, one for the input and one for the output. It's really simple. You have a positive and negative for the input of your solar panels and a positive and negative for the output to your batteries. The solar charger does the rest. I put mine in the same cabinet right behind the microwave. We finally got our very last charger installed, and that is the DC to DC battery charger. I am using a Renogy 60 amp battery charger, which I have fastened on the back side of this cabinet here, right next to our sub panel. The input side to this battery to battery charger is connected underneath, up, and to the OEM Mercedes battery. We have one positive going to the positive terminal of that battery, and we have the negative going directly to the negative terminal of that battery. I actually have the car battery running up to these 2 bus bars right here. So this is actually the positive from the car battery and the negative from the car battery. I can use these 2 bus bars connected to the car battery anytime I want to draw power from there instead of my battery bank. I left some space here because I might put something like a trickle charger that takes power from the house battery and puts it into the car battery so that my car battery never dies. On the output side of our DC to DC charger, we just have it hooked up to the positive and negative bus bars that we ran to this sub panel from our house battery. So the output side of this charger is effectively attached to the positive and negative terminals of our house battery. Very last connection on this DC to DC charger is this dangling wire that I haven't zip tied anywhere yet. This wire just goes to the switch. It's going to be on this OEM looking dash switch once I get these things in the mail, so that when I sit down and I turn my car on, I can switch the DC to DC charger on and it'll be powering my house battery bank. And then when I turn the car off and I want to park, I can simply switch that switch from the driver's seat. 60 amps is definitely the absolute maximum you should be using as far as a charger in these Sprinter vans. In fact, it's a little bit higher than what they recommend. I believe it's capped at 50 amps. That being said, I'm never going to turn this thing on when I don't have the car running. And when the car is running, the alternator is pumping a ton more power into the battery. When I turn it on, it will always be pulling primarily from the alternator. Believe it or not, guys, that sums up the entirety of our electrical project. I will be connecting more devices as this build progresses. Like when we do the water system, we will attach the water heater. But for now, we are 100% done. And I am very happy to be saying that because this was a massive, massive project. I took hours and hours worth of footage. We'll see how long the video ends up being. It's going to be really hard to condense all of this footage down into a short enough video to be valuable for you guys. So I hope you enjoyed this video. video. I hope that you learned something. If you did, slap that like button below to show me that you guys liked it. It makes me feel a lot better about myself. And if you are not yet a subscriber, I would greatly appreciate you slapping that subscribe button. That will let you get notified anytime I drop a new build video. Thank you guys so much for watching, and I will see you guys next time.